Hey, good morning, everyone. This is Prabhakar. I'm Mr Prabhs Uyyala. I'm a delivery architect and delivery manager and delivery architect at IBM, as well as I'm doing a research. I'm a research scholar at JS University. Today, we're going to talk about the real-time anti-fraud tensor-link for checks. So, what is it exactly? Let us see the topics that we're going to cover part of this presentation. Here, introduction to AFTL4C that we named after anti-fraud tensor-link for checks. Check fraud and its impacts in mankind or in history. And AFTL for solution, how overview, how it is, and how it's going to be processed for the anti-fraud check detections, key features and benefits, and key technical implementation, and what is the platform model and conclusion, the final statement. These are the key topics we are going to cover part of this discussion. Let's see introduction to this. How this product is built. This is a AI ML, artificial intelligence and machine learning based solution. We designed, built, and developed as an anti-fraud tensor link for checks in the banking environment to detect any of the check if it is fraudulent or a counterfeit by the user, right? For example, if anybody changed the amount on the check, if anybody changed the signature of the check, somebody did the forgery of the check, somebody changed the payee address, payee name verification, all those things. If anything changed by using the new latest artificial intelligence models, we are going to detect, the system is going to detect whether the check is modified or not. It highlights the importance of the fraud detection in the financial industry and the risk of losing millions due to the fraudulent activities. If you know that check fraud is one of the biggest fraud happens in the history since 1920s. Checks been there in the history for 600 years. The check fraud came limelight from 1920s and 30s onwards. And with the latest COVID surge, due to the government pandemic checks, they are distributing to the needy people and part of the economic improvised packages, those checks being modified, forged, and used by the fraudulent users. We'll talk more in detail about it. The use of generative adversarial networks. GAN is a new way of using a CNN, convolutional networks. It's a generative adversarial networks that's invented by Mr. Goodfellow, Dr. Goodfellow. It's part of his research. He invented this in 2014 and published a paper that bring a lot of traction, lot of new invention, a lot of new inventions and applications in the AI and machine learning. And one of the ideas came out of that is AFTLC, the real-time fraud detection. And about this application, how it can be used. This application is scalable, configurable, and accuracy is more than what industry standard currently we have the fraud detection systems that we will deep dive into in the coming slides. What is a check fraud and its impact? Check fraud inevitable over the years in the banking sector. It's currently in the rise, has to do with something that plays a big role in everybody's lives. Money and more so, checks. Checks has been around almost 600 years and they're now being misused. According to FBI, there is an estimated 18.7 billion US dollars that loses annually every year due to this check fraud. There are over 8 million check a day that get forged just in the US. This has even shown that upward trend as the number of cases this happened increased to 23% in the just 2023. And compared to the numbers in 2022, the data shows that the number of cases has been doubled. Experts are even saying that 2023, it might reach to 24 billion. The revolutionary, the groundbreaking next generation, Dr. Uyyala's, it means my invention, real-time anti-fraud tensor link for checks undoubtedly play a major role to protect our financial institutions and losers, which protects the economy as well. Let's see into that. What is the solution? How FTL works. This addresses the goals of real-time fraud detection. As of now, all the fraud detection systems in the bank, it's not real time. Once you submit the check, it goes to the back office. Then back office people do the manual verification or a systematic verification using a rules engine application. That takes 1 or 2 days to identify whether the check is accurate or fraudulent. So by the time the person who is claiming as a fraudulent, fraudster will claim the money and they go answer it. That's how the bank loses the money. So current systems, how we are using? Current banks are using the OCR, optical character readers, and deep learning together, but that is limited to only finding few objects. And accuracy of the majority of the products is less than 70%. The latest, the new GAN, AI-based, machine learning-based approach, which we trained using our proprietary algorithms by GAN techniques. These will be trained based on the historical database of the fraudulent data and non-fraudulent checks and images, generators and adversaries. So GAN predominantly will have two generators and discriminators. So generators will be trained how the checks will be as it takes an input. Discriminator will go against the check and identify what is the changes has been done by the original checks. The confidence point is used to measure whether it has any potential counterfeit or not there in the check. Let's see in the next check what is the key benefits, right? How exactly it can happen. This product which we built and designed and patented in the US as well as in India, in UK, the scalability, configurable, real-time nature of the AFTL solution. The ability of AFTL is a process of 1800 checks. The speed of the checks, because of that submission, if you see the right-hand side of the diagram on this deck, this one is a patent check, especially for IoT machine. When the check scan through this machine, or it can scan through the mobile application, that comes to this generative adversarial networks, and it will process through the specially built algorithms, and it will complete the fraud detection. And it will identify what kind of fraud it will identify. If anybody modifies the name of the account, it will identify whether somebody modified it or not. If somebody's forged the signature, it will compare the historical data, and it will, based on the pen strokes, based on the way of the writing styles and everything, machines will detect it whether it's a forgery check or not. And also somebody adds an extra dollar, extra money to the whatever the check originally issued, that also can be detected. And somebody updates the check description, that also identified. Anything that it is modified after the original check is issued, 90% of the cases, this can be detected using this new machine learning algorithm that was built as a AFTL for C. What it does, it not only detects very accurately, it also brings a customer satisfaction. Since as soon as when customer submits the checks, by using this application, a bank can say that whether it is a authentic check or not. Once you know this is authentic check or not, immediately you can clear the check and funds made available to the customer. That way it brings more customer friendly and more customer satisfaction to the banks. So how the platform looks like? The platform is the working of the AFTL for C using with this platform. You see the right hand side. AFTL for generator is a feeder which takes the intake from the original check it is submitted, and it goes to the app layer, then the source attribution, and it processes the algorithm and continent retrieves based on the soft weights we have provided, and based on the discriminator selections, it will be assigned to all the check objects. For example, if you see in the check, there is a green and red objects. Wherever check discriminator identifies if there is a potential change or alter was done, that will be detected as that item is detected as a red, and rest of the items will be detected as a green. Based on that, the back office user, the person who is checking the check in the bank, handling the checks in the bank, they easily identify that where was a forgery was done, and amount will not be honored to the person who is fraudster who submitted the check. The working of the ATF using a GAN with the generator and discriminator components. The training process of the generator and discriminator, including integration of a multiple generators for specific check objects, and the use of loss function. The training data source for this discriminator, including the historical real check images and counterfeit checks images that produced by the generator. Generator not only takes the historical counterfeit checks available with the bank, that also generates a possible modification if fraudulent can do it, and it trained and well aware of it before any fraudster comes into that. That is the main advantage of it. Even though you have a very less historical data with your bank, still we can produce a good amount of a possible fraudulent checks, and the discriminator will be trained and ready to deploy in the production to use it. Usually, a lot of AI machine learning applications inside the bank, due to the compliance in the nature banking application, it requires a lot of security protocols need to be followed, a lot of compliance in the nature need to be followed. So this will be take a months and years sometimes to onboard to the production use. But since this model, we trained it with following all the cloud native application and financial security guidelines we followed, this application doesn't require you don't need to reinvent the wheel. So everything is the place. You need to plug into your data and train the model for a month. And the model is already trained with all possible counterparts that could happen. And this can be used within a couple of months in the production. So let's see, what is the final conclusion of this? This proprietary FTC model, trained AML model using a GAN approach, has achieved impressive results by detecting accuracy of 90%. So we made a fraudulent checks purposefully when we process it, and we are able to detect 90%. And by tweaking some of the soft weights, we could see sometimes it achieved 95%, but on average, most of the times we are getting 90%. Majority of the current industry systems is reached only up to 70% or max 80%. But we are happy to announce that this product is the best in the class to reach the 90% of product, 90% with the near real time. And the process of the speed is 62 milliseconds. The solution can be customized and trained with the enterprise own historical data within a few months of the model day. This solution is being patented in the US, UK, and India. And we have a MOU with India, Telangana Tech Startech company, fintech company, Workcog is a fundraiser operating, and we are going to be brought this and introduced it to the market as enterprise solutions with the partnership with them. And what is the value propositions for this environment with one-click deployment? We have this, it's a cloud native application. You can do this one-click deployment. We provide as a SaaS service. You also can deploy this as a on-prem OpenShift cluster in order to get the best results as accuracy, the performance and everything. OpenShift is a suggestible. By leveraging the generative adversarial networks and historical database in fraudulent, non-fraudulent checks, our FTF model improves the capabilities of the financial institution, existing image and validation software. It analyzes various elements such as payee, check number, account and routing number, amount, endorsement, and signature. Most of the bank solutions are, for each of these objects, they have a different application, different solutions. They have to process those. But the single application can process all these verification and detect the checks, and that's the reason it's a faster turnaround for this check fraud detection. Tested on simulated historical data sets, our model demonstrated over 90% of the reduction in the counterfeit checks, processing millions of checks daily with the response of 62 seconds. That's all about my AFTL for C, the check process. This being designed, built, and ready for enterprise rollout. Thank you for taking time and nominating this for Best Research Award for 2023. And I appreciate, I thank you for my guide, Dr. Dhyanchand and Dr. Gaurav, and also the Goodfellow, Dr. Goodfellow, who gave to the world as a birth of, who gave the birth to the GAN model, how to use a GAN. And that's all about me. If you have any questions, please log on to my website, which is antifraud tensor-link.com, ANTA-fraud, FRUAT, tensor, TENSOR, LINK.com, tensor-link.com. You can find all the information about this product. And there is an email, phone number is phone number is available on the website. You can reach out for any more information you want. And thanks again. Thank you for science. Thank you for this research award on the new science innovation. Thank you very much. Have a nice day.